Good morning, all of you. So today we are going to discuss the introduction of PLC. Myself, Ashit Desai, Assistant Professor, Automation Robotics Department, Sri Institute of Technology, College of Engineering. So first of all, we discuss regarding the introduction to PLC. So in the first point, definition of PLC. Second point, basic components of PLC. Then PLC advantages. Fourth point is PLC disadvantage. Fifth point is PLC input and output module. Next point is regarding with PLC input and output instruction symbols, and next point is related with constructing PLC ladder diagrams and latching circuit. So today we are going to discuss regarding the PLC. So the PLC basic components is the monitor. So from that end we are receiving and sending the commands to the system. Then next is about programming device. So this is about the component we have to communicate with memory, as well as we have to requires to be power supply for that system. Then we are requiring the memory. Then we are discussing regarding the input and output modules. So input modules we require for the that sensor. Then different types of switches we are using for the input module for the giving the system to the inputs to the processing for the output module. So in between that there is a memory, microprocessor and power supply there. So power supply is required for input output as well as this microprocessor. So this relate with the basic components of the PLC. So this memory microprocessor is called as CPU. So this is about central processing unit, where the that all the that communication as well as all the data will be processing over here. So this is about the main content of the PLC. Then PLC is advantages. It is having more flexibility, then implementing changes and correcting errors. Then third one is about large quantities of contacts, so it can be converted to the new system. Then lower cost. Then next about pilot running, so there is automatic running which is possible. The visual observations, so anyone can be visualize and observe what happened regarding the system as a input and output models. Then speed of operation, ladder or boolean programming methods. Then reliability and maintainability, ladder of Boolean algebra method, ease of changes by reprograms. So this is about the PLC advantages. Now look at this PLC disadvantage. First point is regarding the newer technology. Because of this new technology, the skilled person is not available. Then second is environmental consideration. So it is about the whenever the industry usage is there. So at that time there is dust particle, then humidity, temperature. So this contacts is available. So we are considering over there, and that type of arrangement we can do over there for the PLC operations. The next fail-safe operation is there. So this is also uh, the making conditions for the PLC. So these are the three disadvantage of the system. Now we are going to discuss regarding some of the manufacturing of PLC. So anyhow, that different companies and manufacture for the different the brandings is under that there are different manufacturers. So one is the Allen Bradley, then ABB company, then Siemens, Mitsubishi PLC, Hitachi PLC, Delta PLC, General Electric PLC, and Honeywell PLC. So they are the name of the manufacturer of the PLCs. The next is about PLC input and output modules. So input modules we are considering. So this is basic part of the PLC. We are considering the different sensors, switches, and encoders. We are considering in the input modules. So this is the important term for the PLC input modules. The next is about PLC output module. So the coil, relay, lamp, siren, valves, and actuator. These are considering the value for the PLC output modules. So this is the input and output module for the system. So whenever you are using the PLC system, so we are using the different sensors and switches. So this is the input. While creating the output is in the signal form, that is we are conducting the coils, relays, lamps, and sirens. So this is about the PLC input output modules. So this is about outlook of that. Then PLC instruction set symbol. So whenever you are mentioning in at the first point is about the normally open switch. So this is about the normally open switch is there. This one is a normally open, and this is called as about normally closed. So when what is the function of normally open? The normally open means what? Whenever the output is on, Whenever the output is on, that means what, input is required to be there. So input is on, output is on, that condition is called as normally open. So that in the other form we can say, if value of this input value is 1, then output is also 1. But in case of normally closed, so it is opposite of normally open. So whenever this normally closed is there, so input value is 1, the output is 0. So again I can repeat for that, normally closed, so this is the opposite of normally open. So whenever the input value is on, output value is 0. So another condition you can say, if it is value is 1 for the input, for the normally closed value 1, then output is 0. So this is about the terminology we are discussing regarding the normally open and normally closed. So this is about the next terminology, that is output energized, that is OTE. Then OTL, that is output latch. So OT is, that means what, output energized, it is your lamp is there, then you can say your that siren is there. So that is conditions we have organizing by the output energized, that is about in output instruction set. So we can indicate by this symbol. Then output latch, so if is your next output is to be depending on your further output, that output, that is we can say output latch. So your continuous output is required to be on, then you can require output latch, that is OTL. Then third condition is about output unlatch, that is OTU. So this is U terms is nothing but your quality of this U, that is about unlatch. So whenever you can output should be it is not continuous, then this output should be off. So this is output unlatch, means what, input value is having that is discontinuous manner, so you can take as a output unlatch. The next is about constructing a PLC diagram. So before that, we are constructing the lamp. So this is about two. Actually, PLC programming are different methods. So we are proposing here for the ladder diagram. So ladder means what? There are two vertical lines is there, and number of horizontal lines we can pressing there. That is called as PLC ladder. So always remember that the left power rail is, that is this line, this first vertical line is called as left power rail, and second vertical line is called as right power rail. So actually the current flows from left to right, that means what, your input value or inputs is in the left hand side, and for the output is on a right hand side. So again I repeat for that. So whenever the constructing the lines, two lines you can draw, that is about vertical lines called as rail, or you can say power rails. So left power rail and a right power rail. So in between that there are horizontal lines is called as rungs. Horizontal lines is called as rungs. And for the left hand side there will be input terms, that is called as input values, because the power is from the left to right. So power is present at the left hand side, that is why we can say power is at side, that is input value is on left hand side and output values are at the right hand side. So there are different number of rungs we can add over here, but only two rails are present. Power rails are only two, but rungs are, we can increase up to number of lines, so we can increase. Okay, according to your program we can increase these rungs. So this is the main condition, or this is method of scanning of PLC ladder. So while constructing this program, so we'll discuss one program for that, and then we can go for the PLC ladder. So if you consider this is about the first AND circuit. So if you say 1 and 2, this is your first input, second input. So you can constructing here AND circuit. AND means what? If your first input and the second inputs are on, then and only output should be on. So this is about the first we are engaging with this AND circuit. AND means what? Your two inputs is on, then output should be on. Suppose one of that input is not there, then output is not generated. So this is about the case for the AND circuit. So already we know that about AND circuits, because two input is are present, then and then only output is are present. So means what, input 1, input 2, both cases your input should be on, output should be. Next, about example of PLC ladder diagram. So first of all, we considering this input value. So first, if it is normally contact, open contact is there, so you can place it, then we can output should be generated. That is about first case. So this is about next about AND circuit is completed OR circuit. So here input 1 and input 2 is there. So if it is any one of that input should be on, then output should be on. Suppose input 1 is on, output 1 is also on. Input 2 is on. If it is, then output 1 is on. So this is about the main case if it's about AND and OR. So we are considering this solving this ladder, how it can be solved. Suppose you know that these two lines, these two vertical lines is called as power lines, or can say power rails. This is about the coils. So different coils are input sections: CR7, CR6, CR2, CR5, CR1, CR4, CR3. So we are engaging with this at the term at a left hand side, and output should be an output at the right hand side. So how it can read, actually scanning is from left to right, so I can read like this: CR7 is off, CR6 is on, then output 1 is on. So this is one method. So CR7, CR6 and output 1. So likewise you can pathway generated, but in case of that CR7 is off, CR6 is on, output 1 on. So CR7 is off, CR2 is on, CR5 is on, then output 1 is on. So this is the third conditions we can, second condition is satisfied. So CR7 off, CR2 on, CR5 on, output 1 on. Next case is about CR7 off, CR2 on, CR3 on and output 1 on. So like this term is there. Next case CR1, CR4, CR3 on, then output 1 is generated. Then CR1, CR4, CR5 and output 1 is generated. So likewise we can scan of the ladder is there. So actually reading from the left hand side to right hand side, because power is from left to right. So here we are discussing latching circuit. So already we know that about AND circuit and OR circuit. So it is look like OR circuit, but it is different terminology because there is having some different actuation method is there. So how it is possible, that is about latching circuit. Latch means it is required a output should be in continuous manner. So if you say that is about start, that is called as S1 button, or can say input 1, and start 2, that is our stop button. So you can indicate like this. So this is about in a electrical diagrams, this is about the PLC construction diagram. So the symbol is like this. So in PLC like this, that is called as normally open. For start button you can case right normally open, and for the stop button you can call it as a that is normally closed, that is NC. And then output 1, that is about to run CR1. So this CR1 is required to be continuous manner, so that is why we can take as a reference. So here run CR1, likewise you can consider this CR1 run like this. So that means what, your output should be in a continuous manner. So when your output input 1 is on, output 1 is on, because of in a continuous format, because of this latch. So this is called as a latch. So this is not a OR circuit, because we are taking reference as it is this output 1 on W0/1 we can write as here also. So that means what, you can take output as a reference. That means what, that is completing a latching circuit. So latching circuits creates a impact that continuous output should be generated. So already we are having this problem. I will discuss with this again, this point. Yes, this is about the point. So this is example of PLC ladder diagram. So switch A, switch B, switch C. So this is about lamp, that is about output latch, which can consider this. Switch A is pressed, lamp is on. Switch B is pressed, lamp is on. So if it is, so any of three switches, if you can on any of three, suppose we can say switch A is on, lamp is on. If it is switch B is on only, then lamp is on. Switch C is lamp on. So likewise, if you are any switches, we can use it. Lamp should be on, but if you switch D is there, So you can press the switch D. What will happen when you operating switch D? That means what? If you are not any contact of switch ABC, so at that time switch ABC, if you're on, it is not affected because switch D is on. Switch D in on means what? There is no sending the power to the lamp. So that means what? If any switches you can ABC uses the no any control over the system because of switch D, because switch D is on. So likewise the example we have setting for the ladder diagram. So in next lecture we'll discuss regarding the same, but we are taking different type of examples over here. So this is about the AND OR circuit. So realizing this about the effect of this. Thank you.